Excuse me, sir.
Yes.
In the previous lecture, engineering material question number 39. Please keep in mind that you will be repeated.
Sorry, question number?
Question number 39.
Okay, 39. This one.
Yes, sir.
I will share this on the WhatsApp. We will discuss these answers on the WhatsApp.
Okay, sir.
The WhatsApp group. There are 2-3 questions which I need to give the correct answer. I will share on the WhatsApp. Make a screenshot.
Thank you.
Okay. So we will study about structural analysis. So let's start. First of all, what is structural analysis? It is most important part of the engineering, especially civil engineering, as it provides all the basic information about the various components like forces and movements which are acting on the members, and what points are there, maximum and minimum, which helps in analyzing, which helps in designing of the structure. So it plays a very vital role, as it mostly structure is dependent on the forces which are acting on that. It determines whether it is stable or unstable. So stability all depends on the various forces and bending moments acting on the structure. So here you can see it's a simple diagram showing the fixed beam and UDL. The first figure, weight is equal to W. I think all of you are familiar about these things. This here it shows two fixed points, and A, B, C is the beam. A and C are the fixed points. A load UDL is acting on it. If you count what is the load acting on this member, so total load will be W is equal to W. Total load W is equal to W into L. L will be the length of the beam member. So just a diagram. We will discuss in detail in the coming slides. So here comes question: what is structural analysis? Structural analysis is the determination of effect of loads on physical structure and their components. So it basically determines what are the effects of loads on the structure and its components. So another question comes: what are you as a civil engineer study as a structural analysis? Structural analysis is important because it can evaluate whether a specific structural design will be able to withstand external and internal stresses and forces expected for the design. As I said, it is the most important part of engineering, as structure is able to withstand external and internal forces depends on the structural analysis. I mean, structural analysis determines whether it will be stable or not. So it plays a vital role in the designing of structure. What are the knowledge areas should focus on? There are many terms like shear forces, normal forces, bending moment forces. Shear forces, normal forces, and bending, it is repeated. 3.3, statically determinate and statically indeterminate structural elements, stability of structural elements, deflection and slope of structural elements. These are the various topics which will be covered in the mostly in the lecture. What are the structural elements should I focus on? Basically, there are three elements: beams, trusses, and frames. Questions we will get on these types. So mostly it will be from beams. There are a few questions on trusses and frames as well. So beams, you can get more questions. what is your strategy for studying structural analysis and get the question answer right and get to the score? It is a basic thinking. Your strategy, feel structure, live structure, and love structure. You are a civil engineer through practice made so perfect. Just to give a general idea, here you can see a building just shown as example. What are the various forces acting on the members and bending moment and bending moment. It is shown like where it is member is bending. So just to show the bending moment diagram. That's a general idea. We will study as that we will understand when we study as per the member in the questions. Here are what are the types of loads that will work on the acting on the structure. Number one is live loads, wind loads, snow load, earthquake load, thermal load, settlement load, and dynamic load. These are the various loads that will act on the structure, which will be considered during the structural analysis, or we can say in the design. All of the previous loads are calculated and given to you in the following shapes. In structural analysis, basically it will give in the following shape, like 25 and 50. These are the total combination of all the loads, which we read before this slide. So it will be shown like this as a summation of all the loads at various points. So like you can see in point number 1, pointed for on concentrated force. Like this 25 kilonewton acting on the single point. That's why it is called as the pointed force or concentrated force. If a uniform load is distributed over the member, as it's shown here, it will be called as uniform load, UVL, UDL, uniformly distributed load. Like W kilonewton per meter is distributed whole along the length of the member. So here are the few bending moment and shear force diagram for various types of members. So once we discuss the question, it will be clear. Each type of figures will be clear. How to draw shear force and bending moment diagram. We will discuss the question, so it will be clear with that. So you can draw all these after studying the questions. So most important thing is sign convention. How to, during the calculation of bed shear force and bending moment, how to calculate, how to take the positive and negative signs. Like when we calculate where to take positive sign, where to take negative sign, you need to keep in mind all these points while calculating so that there will not be error in calculating the forces or bending moment. Like if you see here, if we consider about the forces, in forces, like if you see this point, positive normal forces act normal to the face and tensile forces pointing away from the face. If you see at this point, these two faces, it is taking away from the faces. So taking towards each other. It means it is, sorry, consider this first. Like these two forces are acting opposite to each other and it tends the member to take away from this point. So this will be the tensile force. Tensile force will also always consider as the positive. We will consider tensile as a positive. If there is compression at any point, we will consider as negative. So considering the normal force, positive normal force act to the face and are tensile forces stretching the material. It means there is a tensile force, it will stretch the material, we will consider as positive. Their direction can be upward, downward, leftward, or rightward. Okay. So if there is shear force will be downward or upward. It will, like, positive shear force slice the material in downward direction and have a negative directional sign. They tend to turn the material in a clockwise direction. Positive shear force are plotted on positive y-axis. So if you see this member here at this point, shear force is pointing upward. So if you see, it will tend the member to turn in the clockwise direction. It will turn the member into clockwise direction. So this will be considered as positive. If it is downward side, then we will consider as negative. Same like right side. If you see it is acting on the downward direction, it will tend the member towards clockwise direction. So we will consider it as positive shear force. So next, for the bending movement, we will see two things. First, is bending movement causing sagging or it is causing hogging? Sagging, hogging, I think you know, we will discuss here also. Here you can see, like, bending movement is causing the member to turn to in this shape, upward bending. So this will be considered as the positive movement. If it tends to move this member in this shape, then it will be considered as negative. Any hogging will consider as negative movement, and if it is causing sagging, it will be considered as positive movement. So most important thing is sign conventions, so that during the calculation should be clear and answers will be correct. So here is an example. This is a deck. Simply we can consider as simply supported slab or beam. So car is on the top. So if you see the upper fiber, it will be under compression. It will tend to, I mean, bend in this shape. So lower fiber will be at this point, it will be apart from each other. Forces will be acting apart from each other. It will cause tension to the member. Lower fiber in the upper part, it will be under compression. Like at this point, forces will be tending towards each other. So this will be compression. So in the upper fiber, always there will be compression if this is the situation, and in the lower fiber, it will be tension. So here also same thing shown. Upper fiber, it is compression, and the lower part of the beam, it is tensile stress acting on the beam. Again, sign convention, shape deformation due to bending moment. Like these two bending moments acting in this direction, causing the sagging, so it will be considered as positive bending moment. And if bending moment are acting in this direction, they cause hogging, so it will be considered as negative. So sign convention, positive shear force diagram drawn above the beam. If the shear force is positive, always the shear force diagram is drawn above the beam. Positive bending moment diagram drawn below the beam. For bending moment, if it is positive, it will be drawn below the beam. Again, same thing what did we discuss before. Sign convention about the bending moment and shear force. Same thing is shown here as well. Same thing, compression on the top fiber, tension in the bottom fiber, sagging bending, hogging bending. So two types of bending will be sagging and hogging. It is also same, shown in different way. If you understood the previous slides, then it's same. No need to explain this. Tensile stress in deck. You see here we have support. Load is acting in this direction. So it will tend to bend like this. So bottom part of the beam will be having compression and upper part will have tension. It means tensile stress in the deck. Zero shear is equal to maximum moment. Always bending moment will be maximum where shear stress will be zero. Shear force is zero there in that part, in that section, bending moment will be maximum. So here are different type of supports shown. The internal forces, types of supports and reaction. The internal forces are the ones that hold parts of rigid body together. If you see, this is a fixed support. If there is fixed support, there will be horizontal forces acting on the support, and then vertical forces, and there will be movement as well. If it is simply supported, like this is roller support, we have only vertical reaction. So only vertical forces will be acting. If it is hinge support will always free to rotate. It means there will not be any movement. So there will always be only vertical force and horizontal force, or vertical reaction or horizontal reaction. For any action, there is always a reaction. Like this is simply supported. You put load here, it will be action. On the reaction, to balance this action, there will always be reaction. So reaction will be in opposite direction. Every action has an equal and opposite reaction. Statically determinate. What is a statically determinate structure element and how to analyze? If how to understand that it is statically determinate structure. If unknown reaction is equal to the equilibrium equation, yani if the unknown forces are calculated with the help of these three equations. These three are the equilibrium equations, like summation of fx forces at s direction will be equal to 0, and summation of forces at y-axis is equal to 0, and summation of moment is equal to 0. So this is the golden rule of statics. Anything and everything that do not move in this world is knowing to be a perpetual equilibrium, and it is obeying three golden rules of statics. These are the three rules of statics. So these three equations we will use to determine the various forces and moments acting on the member or the support. So these are the few examples of determinate beams. Here we will able to calculate using these three equations. We will be able to calculate the various reactions and moments acting on the members or supports. This is the most likely example shown here. One point is hinge, another is roller support. Force is acting on that member. Most likely example 2. Same supports are same, only change the force acting on the beam. Like before it was pointed load, now it is uniformly distributed load. Here it shows the shear force and bending moment diagram. Like A and B are the supports, reactions are RA and RB. So we will discuss with the question, so we will be able to, there will be similar question as well. So we will calculate the shear force and bending moment for the members. as per the question. So the beam shown here is simply, let's come to the question. This is the first example. The beam shown below is supported by a pin at A and ruler at B. So A is supported by pin and B we have ruler. Calculate the reactions at both the support due to the loading. So let us suppose. So if we consider point A we have hinge support. Hinge support, there will be reaction in upward direction and there will be reaction in x direction, x axis. So we will use the three equations of equilibrium. Summation MB, yani moment at B is equal to 0. So let's calculate the moment at B. If we count moment at B is equal to 0, consider B. So let's calculate the bending moment. So what is bending moment? Bending moment will be the force acting and the distance between the point which we are calculating or considering. We are taking for the B point. So RAX will be the force acting on A into distance. Distance is 9. So RAX into 9 upward direction. So we will take it as positive because it will tend to move in clockwise direction as per the sign convention which we studied before. So RAY into 9. Then the next load is 20 kilonewton. This was positive. This will be downward direction, so it will be negative. So 20 into distance between these two, from distance between 20 kilonewton and B is 7. So it will be 20 into 7 with minus sign. So let's consider this load. So minus 40 into 4. So this is our equation. If we resolve this equation, we will get RA is equal to, sorry?
RAY multiply by 9. I am not understanding 9. Multiply by 9.
9 will be like this. What is bending moment? When we calculate bending moment, it will be considered as a multiplication of force into distance between the force and the point which we are considering. Like we are taking moment about B. So bending moment will be RAY into distance between B and this force, perpendicular distance from here to here.
Okay, sir. Okay.
3 plus 2 plus 4, really 9. So it will be RAY into 9. Similarly, with negative sign, it will be 20 into 4 plus 3, 7, minus 40 into 4. So if you resolve these equations, you will get RA is equal to 33.3 kilonewton. Okay, we got RA until now. So if we count, summation Fy is equal to 0, yani forces at y direction is equal to 0. What are the forces at y direction? This 1, 2, 3, and this one 4. So RAY plus RBY, both are upward, so we took as positive. RAY plus RBY, and the 20 kilonewton and 40 kilonewton is in opposite direction, so we will take as negative 20 minus 40. So if we resolve this equation, we will get RB is equal to 26.7. Clear? Now let's see the third equation of equilibrium. Summation Fx is equal to 0. Yani forces at x direction is equal to 0. forces at X, we have only one, RAX. This point we have roller support, so there will be only vertical reaction, yani reaction in vertical direction. There will not be any horizontal reaction or any movement due to hinge support, sorry, roller support. So we will get RAX is equal to 0 with this equation. Okay, clear. Here is another example. Example number 2. Determine the reactions at support A and B for the overhanging beam subjected the loading as. Loading is given here. Point A is pin support and B is roller. So let's make the free body diagram. We have load here. One is pointed load 20 kilonewton, and one is UDL 15 kilonewton per meter. So let's make the free body diagram. At point A, we have pin support, so there will be two reactions. One will be in vertical direction, another will be horizontal direction. So it will be considered RAX and RAY. So let's see at point B. Here we will have a vertical reaction only. So it will be considered as RBY. So let's use the equations of equilibrium. So first summation MA is equal to 0. So let's consider at point A, moment is equal to 0. So if we calculate moment at A, how many forces are acting? There is 1, 2, and 3. So about the sign convention, let's start from RBY. RBY into what will be the moment? Force into distance between them. Yani distance between point A and the force acting on point B. So we will consider it as negative because if we see load RBY is tending the member to rotate in anti-clockwise direction. So we will, as per the sign convention which we studied before, it will be negative. So minus RBY into 7. 7 is 4 plus 3. So now let's take 20 kilonewton. 20 kilonewton will be considered as positive because it tends the member to rotate in clockwise direction. So 20 into what is the distance? 4 plus 3 plus 2, yani 9. So it will be 20 into 9. Let's talk about 15 kilonewton per meter. It is UDL acting on 3 meter of length. So whenever there is a uniformly distributed load, first of all, we will calculate how much total load is acting on the member. Yani total load is 15 into 3. Total load will be 15 into 3. Yani 45. So this here it is written 15 into 3. And what is the distance on which this load is acting from A? If there is UDL, so let's see. From here to this point, it is 4 meter. Whenever there is a uniformly distributed load, it will always acting on the half of its length. Yani, if it is 3 meter, so this will be 1.5 meter. It will be acting on 1.5 meter. So what will be the distance? 4 plus 1.5. Yani total distance on which this load is acting from B is 5.5. Understood? If we resolve this equation, we will get RB is equal to 61.07 kilonewton. So let's talk about if summation Fy is equal to 0. From the first equation, summation of movement at A is equal to 0. We got RB, reaction RB, value of reaction RB. Now let's consider summation Fy is equal to 0. So summation Fy yani summation of all the vertical forces would be equal to 0. So we have 1, 2, 3, and 4 vertical forces. So RAY, RBY we took as positive, and forces acting opposite to RAY and RBY we will take negative. So minus 20 acting is in this direction, and 15 into 3. Total load for this UDL will be 15 into 3, the one which I wrote here, total 45. So RAY plus RBY minus 20 minus 45 is equal to 0. If we resolve this equation, RAY we will get 3.93 kilonewton. Okay, we got the value of RAY and RBY. So we got both the reactions, and there is one more reaction, RAX. So if we count forces, summation of forces acting in x-axis as 0, we will get value of RAX. So there is no other force acting in x direction, so it will be 0. So we got here all the three reactions, RAX, RAY, and RB. Okay, clear.
Yes, sir.
This example shown, I think, incomplete.
During exam, calculator will be loaded or not?
It will be simple questions. It will same computer calculator you can use, basic and scientific, whatever is in the computer. Same you can use.
Same we bring to the exam.
You cannot carry our scientific calculator which we used in engineering. It will not be allowed. Only the one which is present. Basically, if you study all the materials, all the questions,
Yes, sir.
I mean, there will not be any need to calculate. You will just see the figure and remember the answer of this question is this one. Even though if you want to calculate, you can calculate on paper, and the basic calculator which we available in the computer, that one you can use. But if you study all, practice 1 or 2 times, you will remember all the answers of the question. There will
Okay,
not be
sir.
any. There will not be any. I mean,
Need of calculator.
So, and these type of equations you can easily solve in the basic calculator as well. There will not be
Yes.
any requirement of scientific calculator.
Yes.
Like if you see the trusses questions, we used to calculate very lengthy. We need to calculate, I mean, on each and every point, we need to calculate the forces acting. So we start from the beginning and we reach at the end. So those are very lengthy questions. If you remember when we studied during the engineering, it was used to lengthy question. If it
Yes.
comes also, there will not be enough time to calculate the whether there is a tension or compression of the particular member. If it is lying inside, I mean, there is no simple truth. It will be not possible to solve everything, or I mean, stepwise all. So questions will be like that. You can able to solve manually as well. So let's see the example number 3. Here we have fixed support. Cantilever beam is loaded as shown. Determine all the reactions at support A. So A support is fixed support. If there is a fixed support, there will be reaction in X direction, Y direction, and there will always a movement as well. Okay. And this is simply a cantilever, so there is no support on this end. So here shows the free body diagram. At point A, we have two reactions, RAY and RAX, and there is one moment at A acting, let's suppose acting in this direction. So let's calculate. Like if you see this force is acting in this at an angle. So if a force is acting at an angle, we resolve the components of the forces in x-axis and y-axis. For example, here it says this 3, this 4. If we resolve these two forces in x-axis and y-axis, it will be like if suppose the force is F. This will be F cos theta. This will be in in y direction. It will be F sin theta. Okay. So let's start. Summation Fy is equal to 0. Yani forces at y direction is equal to 0. So what are the forces in y direction? We have Rax. Okay, we took as positive because it is tending to rotate the member into clockwise direction. So we took Ray minus this 5 kilonewton is uniformly varying load. So for uniformly varying load, what will be the total load acting on the member? It is simply, if you see 5 kilonewton per meter, this will be the at this point 5 kilonewton. So it will be going down. So if we have to calculate the total load acting on the member, we will calculate the area. Like what is the area of triangle? Half into base into height. Okay, half yani 0.5. Base, the force is acting from this point to this point. So we have total length of acting on which force is acting is 2 meter. So length will be 2 meter. What is the height of the triangle? This will be the height. This 5 kilonewton per meter. This magnitude of the force is shown as 5, which will be the maximum at this point. So it is 5. So it will be 0.5 into 5 into 2. So we calculated the total force of this UDL. Then another force which will be acting here, it will be at this point. So this force is acting at an angle. So we will find out the vertical component because we are calculating the summation of Fy, any forces at y direction. So we will find the vertical component of this force. What will be the vertical component? Vertical component will be this one, F sin theta. Yani F is 20, force is 20 kilonewton as shown here. What is the sin theta? Sin theta is always perpendicular upon hypotenuse. What is perpendicular shown? Perpendicular is 3. As is here it is written. It will be 3. What is hypotenuse? Hypotenuse will be this part of the triangle. If we calculate the hypotenuse, how we will calculate? Hypotenuse is equal to under root of 3 square plus 4 square. So it will come 5. Clear? If we resolve this equation, we will get Ray minus 5 minus 12 is equal to 0. Value of Ray will be equal to 17 kilonewton. Okay, we got Ray. Now we have to find moment and Rax. So let's find Rax. So if we summation fx is 0, then the forces at x direction is equal to 0. So x direction we have RAX. If you see this RAX trying to compress the member, so we will consider as negative. Compression we will consider negative, and if there is tension in the member due to force, we will consider. So minus RAX. Then see another what will be the another force in x direction? It will be at this point because this is acting at an angle. So we will take the component at x axis. What we have at x axis? We have f cos theta. F cos theta yani f is 20 kilonewton. Theta is base upon hypotenuse. Base we have 4 here. Hypotenuse again 5. 4 divided by 5. If we will get minus RAX is equal to 16. Here we get minus RX is equal to 16 or RAX is equal to minus 16. If there is minus, it means we have RAX like we have considered in this direction in positive. It is coming negative. It means actually RAX is acting in this direction. Because we got here as a negative value. Okay, clear. Now we have RAX, RAY we got and RAX we got. Now we have to find out of the moment. So
Excuse me,
let's
sir.
calculate the moment at A is equal to 0. So at point A, what are the moments? Yes.
Sir, your sound cannot properly hear.
Any doubt?
Your sound cannot
Now
reach
is
here.
it okay? Can you hear me?
Hello.
Hello.
Hello, sir.
Can you hear me? What about
Now,
others? Can you give feedback?
hello.
So the sound is breaking actually due to connection.
Hello.
The sound is breaking. Your sound is breaking.
Yes, can everyone hear?
Your sounds are still breaking.
Due to connection?
Yes, I
Sound is
think.
breaking. Still breaking. If I'm speaking, I mean words are being cut or what type of? I mean if I speak any word, it is not coming fully, right?
Yes. Sir.
Hello.
Yes, sir.
Can you hear me now?
Not properly here, sir. Your sound break again and again.
Okay. Shall we resume? Break yani words are breaking. If I speak any word,
Yes,
you
sir.
are able
Breaking. Your words is
to
breaking.
hear full part or it is
Half cut.
coming partially. Hello.
Partially cutting your
Breaking.
sounds.
Hello. Okay, service. Sorry. But I can hear you all. I don't know what is the issue. Hello.
Yes,
Hello.
sir. Hello.
Hello. Can you hear now?
Sir, your sound still
Hello.
problem. Sir, please reconnect again.